Hello, we are discussing about GATE 2015 ECE paper. Look at the circuit shown. Assume that the diodes D1 and D2 are ideal. In the steady state condition, the average voltage VAB across 0.5 microfarad capacitor. What is the voltage across? Average voltage across 0.5 microfarad capacitor that we are going to find. Okay. The same circuit can be redrawn like this. Okay, where we are going with capacitor and it is the diode D1, and next this is diode D2 followed by a capacitor C2. Okay, so this is C1 and it is C2. Voltage across this one is VAB plus minus, and it is D2, this is D1, and it is given as 50 sin omega t is the voltage source. C1 is 1 microfarad, C2 is 0.5 microfarad. Okay, now what happens to these capacitors and what can be the average value, that we will check. So say we are going with one sinusoidal waveform. Okay, and we are starting from negative half cycle. You can start with either positive half cycle or negative half cycle. This is one complete cycle, okay, which will be consisting of negative half cycle as well as positive half cycle. Next cycle is this one, again that will be consisting of negative half cycle, positive half cycle. So during negative half cycle, during negative half cycle is nothing but this will be minus and it will be plus. So you are applying positive towards P side of the diode, and this is N side of the diode which is connecting with N side. So D1 is forward bias, and D2 is reverse bias. For D2 you are applying negative and this is going to be connected with positive. So that D2 will be reverse bias, D1 will be forward bias. Since it is ideal diode under reverse bias act as open circuit, under forward bias act as short circuit. So simply the effective circuit is going to be for this one. It will be looks like a capacitor where the diode is going to be conducting with short circuit with the voltage source connected in this way, plus minus. So as the current is flowing in this direction, capacitor stores in this way. So VC1 is equal to, under steady state, okay, since the diode is ideal, under forward bias RF, forward resistance is 0, so the time constant is 0. Within no time capacitor charges to the final value. Capacitor generally charges with respect to time constant. Time constant is nothing but product of R and C. R is the effective resistance during the current path and C is the capacitance during the current path. So the resistance present during this path is only the resistance across diode. Diode is forward bias and it is ideal diode. Ideal diode is nothing but acting as short circuit under forward bias, so resistance is 0. So 0 time constant for the charging. Within no time capacitor charges to the final value. So VC1 will be 50 volts. VC1 is equal to 50 volts. Okay, during negative half cycle capacitor C1 charges to 50 volts and with polarity indicated like this. Now we are coming for the positive half cycle. During this positive half cycle is nothing but now it will be changed. Okay, this is positive half cycle. During positive half cycle this is plus and it is minus. You are going to apply maximum of 50 sin omega t, peak value is 50. As you are applying this one, plus 50 and this is again plus 50 from the source, plus 50 volts again from the capacitor. So total voltage available for this point is 100 volts plus 100, and that plus 100 it is connecting with negative side. So D2 is forward bias and D1, now if you observe, D1 is with plus 50, this point is at 100 volts. So plus 100 volts is on N side of the diode 1, and for this diode this is connected to negative terminal. So N side is more positive, so that diode 1 becomes reverse bias. So during this positive half cycle, diode 1 reverse bias, that is acting as open circuit. Diode 2 is forward bias, that is acting as short circuit. Okay. Now the circuit is going to be, equivalent circuit is looking like this one. This is capacitor and it is short circuit, and this is one more capacitor, and this diode is acting as open circuit, so I have not drawn. And this is the voltage, plus minus is 50, and this is VC1 plus minus, that is 50, and it is VC2 which is equal to VAB. So apply KVL. KVL is equal to plus 50 plus VC1 minus VC2 is equal to 0. So VC2, which is nothing but VAB, which is 50 plus VC1, that is equal to 50 plus 50, whose value is 100 volts. Okay. So the average value across this point is going to be 100 volts. Capacitor is going to be charging towards 100 volts with sign as plus minus. So during the next half cycles also, next cycles positive as well as negative, the capacitors are going to be held at these voltages only, 50 volts and 100 volts. So value of voltage across capacitor is 100 volts DC, and voltage across C1 is 50 volts DC. So we are going to calculate across C2, that is 0.5 microfarad, which is equal to 100 volts. So the right answer for this question is 100 volts. Here we have started from negative half cycle, but you can also start from the positive half cycle. If you are going to start with positive half cycle, then diode 2 is going to be forward bias, diode 1 is reverse bias. By that time voltage across C2 is going to be 1/3 of 50 volts. Okay. 2/3 of 50 volts, because C1 C2 follows the opposite way. So 100/3 volts you will get, but during the next positive half cycle it will reach as 100 volts. So first cycle, whenever you start with positive half cycle, first positive half cycle and next negative half cycle, that complete cycle is going to be treated as transient response, and from the next cycle onwards you will come into the steady state response. Okay, so during the steady state response, these are the two cases you are going to get. So don't bother about how you are going to start. According to the problem I have started, but you can also start from positive half cycle, but you have to calculate first positive, second negative, second positive, second negative also to get the steady state. Then you will get the answer as 100 volts. Okay, thank you.